Okay, so I'm going to do this problem. It's this problem right here, but I want to keep all this work from the previous problem, so I'm just going to put it down here. Okay, and I'm just going to follow along these steps that I have highlighted up here. Okay, so step 1 is to find the parameterization. So the parameterization, I can either do the Cartesian coordinate, but notice I want the part of this that is below the plane z is equal to 4. So in other words, I want z to be less than or equal to 4, so I want 4 is greater than or equal to x squared plus y squared. Okay, so this tells me that x and y lie in the circle of radius 2 centered at the origin. So D is a circle of radius 2. Circle of radius 2 at origin. So it makes sense to take the polar coordinate parameterization. The next step is to compute f evaluated at the parameterization. So then r of theta t, this is t cosine theta, t sine theta, t squared. The next step is to compute f at the parameterization. The first component is x times z squared. Z squared is t to the power of 4, so this is t to the power of 5. Cosine theta, then we have yz squared. This is t to the power of 5. Sine theta, and then t to the power, minus 2z cubed. This is minus 2 times t to the power of 6. Okay, so step 3 is to compute r theta cross rt. We saw in a previous video that r theta cross rt is equal to 2t squared cosine theta, 2t squared sine theta minus t. And now we check the orientation. That's step 4, check the orientation. Okay, so this shape is an upward facing paraboloid, and we want the outward pointing normal vector, so that means the z component should be negative because in the z direction is pointing down. And that's right, because t is positive, the last component is minus t, so this is the right direction. Step 5 is to compute f dotted with r theta cross rt. So this is going to be 2t to the power of 7 cosine squared theta plus 2t to the power of 7 sine squared theta plus 2t to the power of 7. This is equal to 2t to the power of 7 times 2, because cosine squared plus sine squared is equal to 1, and this is 4t to the power of 7. Okay, and then the final step is step 6 to compute this integral. So the integral, okay, so the parameter domain is the circle of radius 2 centered at the origin. So t is going to go from 0 to 2. Theta goes from 0 to 2 pi, and we're integrating 4t to the power of 7 dt d theta, and this is equal to 256 pi. Okay, so this, again, long and tedious, several opportunities to make mistakes. So you look for me to make more videos where I do more surface integrals of vector fields, because I think this and the subtleties between this and surface integrals of scalar fields and orientations and stuff like that can be a stumbling block and can be difficult and tedious.